Right, so getting back to our check for win conditions. Here we are going to pass who is the player, because remember our moves will register all the moves in the game, and then obviously we want to pass the moves. So we say for player, and we're going to pass boolean. So it's gonna be player 1 or player 2 here. Player 1 will be true, player 2 will be false. You can say for player 1 actually here, or we have player ID, no, player 1 bool, and then we say in moves, and I'm going to pass array of move object, and again very important that this is an optional. So let's think what we need to do. We have an array of moves, or actually an array of things that can be optional moves. So it may be a nil or a move. The first thing we want to do is remove all nils, because if we have nil, we don't want to evaluate it. This move wasn't used yet, so there is no need to check for it. So let's do let player moves equals, and we access our moves, and then we say compact map, and actually we are doing the same thing here, but we are not counting them to be 9. We just want to remove all the nils. So let's just curly braces, $0, and this will remove all the nil objects from our move. Once we have removed the nils, then we have some moves left. Now we want to check if these moves belong to our user 1 or belong to our user 2. So I'm going to say filter, and we want to get only the moves that belong to this user, and for that we say $0, which basically goes through every single object in our array, whatever is left after we remove the nils. And then I'm going to say is player 1 equals player 1. So remember, is player 1 is a boolean. So whatever we pass here, if our player 1 is true, so this is player 1, we will keep only the moves that belong to our player 1. And here actually we need to have a curly brace. And our player moves will be filtered our moves. We remove the nils, and then we will filter it down all the objects that belong to our player. Once we have our player moves, what we want to do is now to get the player positions. So here we just have move objects, and also we have a pattern of sets which are the win patterns. So in order to compare our moves with these sets of win patterns, we want to convert our moves into sets themselves. So it will be easier to compare two sets together. So I will say let player positions equals set, and we are going to create player moves, and we are going to map them, and let's say $0. So for every move in our player moves, we want to get the board index. So we will create a set with the board indexes. We don't need this here, or no, actually we do. So we will create a set of these board indexes, and once we have these sets of our positions, then we can compare with the winning patterns, and this will be our second move. So let's say for pattern in win patterns. So we want to get for each possible win pattern. And actually we need to pass where pattern is subset of, and here we are going to pass our player position. So we check if our player position matches with any of these sets, and if it does, we are going to return true. And let's do this one-liner here. And if it doesn't, we just say return false. So the win position is false. If we find any pattern in win patterns that will match our player position, then we're going to say yes, our past player, either player 1 or 2, has a winning set. So that means that player has won. So now with these two functions, we can go ahead and update our process player moves function. This one we will leave. Check for win. Let's say if check for win, and we are going to say for player, and again I'm going to hard code this and say true, because right now we can do that only with our player. And in moves, I'm going to pass our game. Oops, we are not there. Game dot moves. So if this is true, it means we have won. Let's for now say print. So that we know that our user has won. And then we want to return, because we don't want to continue and check for draw in case if our user has already won the game. So this will be deleted, and if it's not the case for winning, we say if, and we say check for draw in moves, and again we say game dot moves. And here we are going to again say a print and a return. So a print will be draw, and then we want to exit the function because we don't want to do anything else. Not that there is something else to do here, but anyhow. For blocking our move, remember our game has this where is it? Blocked move for player, and here we are going to just put the ID of our player. So we need to just this is a matter of updating our game. So say game dot blocked move for player ID is equals to, and I'm not going to hard code this now. I'm going to say player 2, because we want to check if any of these prints are printing, and if I block my player 1 after the first click, we won't be able to click more. So let's let's keep it player 2 and run our game, and we're going to check if we can win or if we can draw. So I'm going to click 3. So, oh, it says you have won, and of course I can continue playing. It still says you have won because this set is there. If it's full, we should get also, we're not getting the draw because it exits once we get this. So what to do here? Basically we cannot check our draw because we only can enter X, and we always win. So I'm not going to change the code again to be able to register X and O so we can test fully the draw. Just trust me on this. If the moves are exhausted, there are no moves, we are going to get the draw printed out as well.